That's why you have me.
Well done.
So, I discovered that one of the questions on the homework is much, much, much harder than it looks. Actually, the steps that you would go through in order to solve it are very easy, but the actual arithmetic is total pain in the
Easter?
derriere.
Number 3
Yeah.
or number 5?
What?
Both of them here.
Or is it number 18?
It's the one where you've got charge density e to the minus r over a. Constants out front.
It's a pain in the neck.
And then you're asked to find the electric field, right? Which is easy. And then from that, you're asked to find out where it's a maximum.
Which is also easy.
Is it?
I just went my calculator. Well, I found it a pain in the neck to do that because I kept
To
trying
do
to
this in
think
closed form
is
is messy.
Is it possible to form it out?
Yeah, because it's only.
Yeah, it must be
it's hard to
possible,
read.
because if you plot it, it looks like this. There's the maximum there.
You can factor a polynomial up to or x.
Yeah, but there's also
Yeah.
there's each of the negative r. Where
Yeah, but
Oh,
that drops out.
Those are
Second
constant.
derivative.
Look, Wolfram
They don't
Alpha
function.
couldn't do it in closed form.
Yeah. So I'm just labeling this PIA.
Constant that that's not all
All right,
by each
and
In actual
yeah, right. Pain.
Oh, okay.
All right.
Don't bother
I'm
doing
gonna,
closed
in
form.
terms of the grading, we're gonna take a very gentle attitude with. I definitely want to see this. Right. You've got to be able to do this.
Isn't that pretty messy because of the sphere
No, that-
form of del squared, or the divergence?
You don't
This
need to use
is
the
really
divergence.
easy. You could use divergence if you like, or instead of divergence, you could use the divergent theorem, and don't do the differential form, do the integral form.
Okay.
Gauss's law. All right, use Gauss's law.
Okay.
Spherical symmetry.
From here to here, Gauss.
And then for the electrostatic self-energy, do you want us to square that E function and then integrate it over all space?
I thought it was just from 0 to A, personally, but
No, it's overall space. I would be very impressed with the person who does that. Okay, but at the least you should write out what you should do, and take it out to its glorious.
A form that's like series to integrated.
Yeah, and then at that point you say Wolfram Alpha wouldn't do it, or Maple wouldn't do it. So I'm not going to do that.
Well, maybe it's
well, from 0 to A, my calculator did just fine, but it spat out a number that couldn't be
Yeah.
right.
Here's something that I would like you to do. Unfortunately, I didn't assign it, and if I teach this class again, then I probably would do that. I'd actually like you to plot, go to your Maple MATLAB, whatever, and actually plot,
Yeah, that's what it's.
all right, this should be easy. I haven't done it myself, because I'm still
It looks
installing
approximately
Maple.
like that.
But once that's done, I should have no trouble. I could actually do some MATLAB too.
calculator, first edition E calculator could probably do that.
Yeah. But actually, turning it into, I've been told by upper level instructors that most of our majors are not very good at actually representing something, making a graph, or making a 3D graph, with the computer. Doing the calculation they're fine with, but then actually putting it out onto a piece of paper or onto a document that allows people to read it, they're not so good at that. Right? So I'll start assigning you things where you have to actually do that. What's so funny?
Why are physics textbooks so sad? Because they're full of problems.
I haven't heard that one before, but I'll be using it in the future.
Thank you very much.
You're welcome. I figured that'd brighten
That
everybody's
was
day.
beautiful.
The amount of baseball that used, that drew.
Okay,
I just remember.
so everybody was wondering about this problem? You're clear on it now?
So many counts is a lot.
Which is that, were you
I
here?
started the week.
Were you here? Were you
No,
here?
not the PIA.
Okay, so that's pain in is a letter that, a word that starts with pain,
Yeah, because
right?
I put the equation out and I haven't done
Yeah. So the way I'm gonna instruct Wei Ting. Oh, I discovered why she's not grading. Not being so diligent about grading. She defended her thesis yesterday.
Do it.
So she had to finish. She had to write the thesis, get it in, and actually defend it yesterday. So she has promised me that she's going to get on it, and that we're going to get a lot more homework back graded more quickly.
Yeah.
But on the other hand, she's actually completed her PhD, and she's leaving at the end of the semester. So I have actually no levers with which to get her to do that.
So it's like the advanced version of Senior Slacker.
Yes, that's what it is. But I actually I know her, and I feel pretty good that she's going to get back on it, grading things on a regular schedule. But none of you have actually gone through the process of writing a thesis, getting it all together, and defending it. I'll just tell you that it's extremely stressful. And I understand now why she was falling behind her grading on. Okay, so back to this. If you, you should lay out the logic and write out the expressions, but at some point, somewhere around here, you're going to realize that it's getting unmanageably large. Which it's just, I mean, I looked at the problem and I thought easy peasy. And because, you started with that, big deal. And I took a glance at Ohanian's solution, which looked short and sweet. And then I realized when I was asked some question about it, and I went to look at Ohanian's solution, I said, this must be easy. Ohanian worked it to here and stopped. And then he said, and then all you have to do is differentiate it, and then integrate that. So it's pretty clear that he decided that it was just more work than he was willing to do. And if he's not willing to do it, I'm not willing to ask you to do it. And I'm not willing to do
So
that.
we should start.
So you set it up.
Okay.
Show me what you would do. How would you find this?
Okay, sure.
Right? We want this right.
Yeah, I
Okay? And then show me how you do this, and then show me how you do the total energy.
Okay.
Okay? Okay. What else? I really like the capacitor problem.
Yeah, the problem
That was very nice of Loki to do something similar.
You did?
He did.
Okay.
He did making it wider rather than moving any of the dielectrics.
Okay, yeah, so the key there is that you write down the total energy, and then you take the derivative of the energy with respect to the position of the step. That's what I did.
I think that all the units that are in like
Dynes.
Dynes per horse.
Units, centimeters, I completely, actually I am curious in, so your introductory education was all at UCL,
Yeah.
right? Did they use electrostatic units? Or did they use,
They use the units that are in rivets.
yeah, so that's MKS.
Yeah.
MKSA.
Yeah.
Right. So that's what we use MKSA all the way up to this course. And then,
And then after
Throw it in the trash can.
then, yeah, well, actually it depends. There's a divergence that occurs. After this course, the particle theorists and experimental particle people stick with ESU.
Oh,
And one half of Jackson.
And all the people who actually need to do things go back to MKSA.
And then one half of Jackson.
Yes, actually, the graduate level text. There's a somewhat interesting story there, graduate level text in this topic is a book by Jackson, Electrodynamics, I think it's called. He made an agreement with Ed Purcell a billion years ago that they would write their books in CGS, the SU system. And Purcell really believed in this. And he's written this beautiful book on introductory electromagnetic theory, which was supposed to be for freshmen, but no way it's for freshmen. That's all in CGS, Gaussian section. But then Purcell died, and after Purcell died, the next edition of Jackson, he decided to make half of it MKS and half of it CGS. And it's horrifying. But that's what he decided to do.
Why? Because they didn't want to change the other guy's stuff.
No. Purcell, they wrote two separate books. And I think that Jackson decided to, I haven't looked at the newest version, but I think that what he decided to do was to take the materials, I think it's probably electrodynamics, for which CGS units are more natural, and do electrodynamics and CGS units and electrostatics and KSA units.
Yeah.
Or vice versa.
Basically, he's just.
Yeah.
Yeah.
You mean an SC?
Okay, so, well, let's not, I think he's still alive, and probably this is going to get posted somewhere on YouTube. So, he's actually really a fine person, but he did a bad thing. Okay, so everybody's okay on the capacity problem?
I have a question. Can you just go over energy and electricity? Kind of
Yeah, okay. Some constants. Oh, I think I know what they are.
Where are you at?
That's it.
That's it. Okay. And so for a linear dielectric, like we have.
Yes. For this now, finally, you actually have a linear dielectric. So D is equal to epsilon. Did I get that right?
Yes.
E.
Is that the external electric field applied to the dielectric? Or is that the?
Which? This is the electric field, the actual electric field inside the dielectric. This is, if you want, in this case, it's the electric field due to the free charge Q that's put on the capacitor.
So D is.
So you got a total charge Q
Right.
on the capacitor, which is going to redistribute itself,
Correct.
right? In order to make what? The electric field continuous. But what that just ends up being is that electric field's the same everywhere. So G over here is going to be equal to epsilon.
Right. Okay. Okay. So
what's going to happen, by the way, is then the charge density here goes up.
Right. Okay. So if we were using the electric, if we calculate our electric field, instead of replacing E, we need to, or instead of replacing D with epsilon E, we need to replace E with
Yeah.
E over epsilon.
That's what I would do. Yes.
Change that.
Why not replace D with epsilon E because we know E? E is.
Oh, is the potential difference between the
Did
two?
we
Yes,
have
you're right.
five?
E is the same here. So yeah, I have let's call this V1, V2. Right. Sorry. E is V2. I don't want to do this whole problem for you. Over D.
Right.
This is what I'm going to say. Okay. So now I know the electric field everywhere.
Even inside the dielectric.
Oh yeah. It has to be. The difference in potential between this point and that point has to be V2 minus V1. And the relationship between potential and electric field is
Is that regardless of material.
right.
So you
So
do
you're right.
replace
Right.
you do replace D with epsilon.
Yes.
Yes.
Okay. I just wasn't entirely sure.
Yeah. It appears, but I haven't looked to see where I don't know exactly what Ohanian did, but he has a solution to this.
Yeah.
And he has a plus sign there.
No, he's in negative end. His,
Okay. In his actual written out solution,
his,
he has a plus sign there.
and it says the force is in.
But it may be a question of what he defines X to be.
Yeah. Because I got the opposite, depending on how you define it.
It's possible that he said this was X and this is D minus X.
You get a positive when you find d minus x is x.
You should. That, to me, that's the definition. Right. But the question is, how did you define X?
No, yeah.
So that's the last problem.
Okay, so you don't actually have to calculate the energy in the proton.
What?
You don't actually have to calculate the energy in the proton.
You do. You do because you can. I'm sure you can do it.
We believe in you, Brian.
Actually, why not, it would be interesting, you got it all set up. Why not, instead of asking for the closed form solution from Maple or Mathematica,
Well, the open form solution should be.
just have it calculated numerically.
And borrow your computer?
What do you know? And then you got an idea of what the magnitude of the energy is. And it should come out to be, actually, I don't know
my
how
calculator.
many
I got something on the.
ergs it is. But I'm going to say that if you do this calculation, you'll find the self-energy is of order 900 million electron volts.
That's not what I get at. Unless
What?
my units were completely wrong.
You should get the same order of magnitude
As the mass. You should
Yeah.
get about the mass.
I'm well aware. I got something times 10 to the 7 mega electron volts.
Then you did that wrong.
He knows.
Okay.
I'm just saying.
There's another joules.
Any questions about,
There is a way to use symmetry for the first problem, right? Simple symmetry.
for the e to the minus, which one are we talking about?
The first problem, 5.3.
Oh,
Yeah,
yeah.
the sum of both with respect to one charge and J and I.
Okay, look, I'm
I
gonna,
want to do 64.
probably some people are gonna be very unhappy with me when I do this. But I'm gonna give the trick to everyone who hasn't done it yet. Because if you actually try to add up, so the way to do that, this problem is the potential energy is equal to the 1/2 sum over all particles twice, Qi Qj over Rij squared, Rij. Okay. So it is.
It's that messy thing by James Conner.
That's it. Okay? The problem is solved. All right? But if you're going to do this over all of the terms, you're probably talking about, I don't know, 56 terms. Something like that. All right? You don't want to do that. All right? So I'll be right back. Turn that off for a moment if I can figure out how to turn it off.
Well, the batteries.
No. I think if I press this red dot thing.